But if I move along now onto some practical elements, as an examiner and as a maths teacher, I always see some very, very common mistakes. And algebra is the space where these will happen at ordinary level and at higher level. And I think you often know yourself if you've made this mistake, because you might get an equation with some mad looking numbers, or the question might have asked for something in third form and you get a whole number. So you've slipped and you've lost something along the way. And I know it's really difficult to check your work. As a mathematician myself, I find it so hard to say, oh, I'm going to go back and check over everything I've done. But if you have made that mistake, check over and keep an eye for some of these very, very mistakes that I'm going to show you what they are and what they aren't. So if I jump over to my tablet here, the first mistake, I saw it today in class alone with 2 students in 2 different groups, the sneaky double minus. So when we're simplifying this, 3x minus in brackets, 2x minus 5, some people often think that there's a -1 multiplying into that bracket. So what I need you doing is saying we keep our 3x, we multiply the -1 by the 2x to give me -2x, and I multiply the -1 by the -5 to give me a +5. That's the mistake I always see. Some people say it's -5. So that's naturally going to skew the rest of your solution working down with that. And when we simplify this, we get x plus 5. So I want you being very careful with that double minus. So if your solution isn't working out for you, jump back and say, was there a double minus missed anywhere? So that's the first. Next up is the silly mistake made in squaring. So if I have a look here at x plus 4 all to be squared, I see the best of mathematicians turning around and saying, Stephen, that's x squared plus 16. You square the x, it's x squared. You square the 4, it's 16. That is absolutely not the case, okay? And that's what makes us lose our marks in our quadratics. It loses our marks in our simultaneous equations. Anything with lots of expressions, you need to be careful. So let me show you the 2 kind of common ways I see students do this. And I want to show you kind of a bit of a shortcut or a trick that I often use to deal with our squaring. So I know in terms of the first way, if we have a look at way 1, squaring means to multiply something by itself. So x plus 4 squared would mean take x plus 4 and multiply it by itself. And I know a lot of you would come along with your arrows and do x by x, which is x squared, x times 4, which is 4x, 4 by x, which is 4x, and 4 times 4, which is 16. And you tidy up the middle there to give me x squared plus 8x plus 16, which is the correct answer. So you can see in the incorrect one that I crossed out, we wouldn't have had the plus 8x. So that's one way people would do it. Another way that has become quite popular lately, and some students would use it maybe to start off and to build themselves up into working with quadratics, is using the lovely little array or area model where we have our x and our plus 4 on the side and our x and our plus 4 on the bottom, and you're thinking, okay, let's get the area of each square here. So where this first little red x is, I'd be multiplying x times x to give me x squared. I'd be doing x times 4 to give me 4x over here. On the bottom, we'd be multiplying 4 by x to give me 4x, and 4 times 4, which is 16. And then when we come to tidy this up, I'd be getting x squared plus 8x plus 16, the exact same answer in the first way. So look, there are the ways that I know you're familiar with, but I want to show you a quicker way to deal with squaring, seeing as we do it all the time. So if I take my x plus 4 and I want to square it, the 3 things I'm going to say here are: first, square the first term; second, square the last term; and third, double the first by the last. So what do I mean by this? Square the first term. The first term in that bracket is x, so square it. I get x squared. Square the last term. So the last term is 4. 4 squared is 16. And I have to double the first by the last. So when I double the x, I get 2x. And 2x by the last term, 4. 2x by 4 is 8x. There we have it. X squared plus 8x plus 16. And I want to show you this for a few more. So what if we had y minus 3 all to be squared? Well, let's go through it. Let's square the first term, square the y to give me y squared. Square the last. So I'm squaring minus 3. So minus 3 times itself. Minus 3 times minus 3 is plus 9. And I want to double the first by the last. So double the y to give me 2y. And 2y by the minus 3y is minus 6y. And if we have a look at one more scenario here, if I have 3x plus 1 all squared, I go ahead and I square the first term. So 3x squared, square the number, square the letter, gives me 9x all squared. Square the 1 at the end. 1 squared, 1 times 1 is 1. And I double the first, so double the 3x to give me 6x, and 6x by the 1 gives me 6x. So take your pick, whatever way you do it. I simply don't mind, so long as you don't tell me that the answer to that original question is x squared plus 16. So once more, the wee shortcut is square the first, square the last, double the first by the last. Other mistakes we see here come into play when we fractions. Sometimes these just naturally come up in certain equations. So if we have a look at our first one, our 3x minus 2 all to be squared, which is, 3x minus 2 over 5x all to be squared. Now, how do we square a fraction? We have to square the top and square the bottom. Okay, so I'm going to square that top line by using my rules. Square the first, square the last, double the first by the last. So when I square the 3x squared is 9x squared. Square the last, square the 2 to give me 4. So minus 2 squared is plus 4. And I double the first by the last. So double 3x is 6x. 6x by minus 2 is minus 12x. So we've squared the top. I often see that folk would forget to square the bottom here. So if I square 5x, square the 5, 25, square the x, x squared. That's how we square a fraction. So top line following our rule, square the first, square the last, double the first by the last, all over the bottom squared. And lastly, this one's maybe more so for the higher level folk. Let's do some uncomplicated cubing here. We know squaring means times something by itself twice, and so cubing means multiply it by itself 3 times. Now, as an examiner, I always see some very creative ways as to how people would go ahead and cube a bracket. But the reality is we can only do 2 brackets at a time here. So I'm not going to show you all the versions, but I hope you'll agree with me that multiplying a bracket by itself means squaring it. So I could write those last 2 brackets as x plus 2 squared, and I'll keep the original x plus 2 in front. So what I'm going to do now is do x plus 2 times x plus 2 squared. So if I keep the x plus 2 in front, I now know how to quickly square a bracket. I square the first, x squared, square the last, 2 squared is 4. Double the first by the last, so double x, is 2x, and 2x by 2 is 4x. And all we're going to do now is fire in the x to all 3 terms and then fire in the 2 to all 3 terms. So when I multiply x into all the terms, I get x cubed plus 4x squared plus 4x. And then we're coming along multiplying 2 into our pink bracket to give me 2x squared plus 8x plus 8. And now what we can do is add together our like terms. Our x cubed is out there on its own. If I add together the 4x squared and the 2x squared, it gives me 6x squared. And then I'm going 4x plus 8x, which is 12x. And then I have my plus 5 at the end. So if you're in your exam, Christmas exams are coming up, mocks are coming up in January for the 6th years, and the real exams June this next year or June 2027, you need to stand back and say to yourself, right, if I've made a mistake in my algebra, have I made a mistake with the double minus? Have I made a mistake squaring? Have I made a mistake cubing? Or have I made a mistake with my fractions? It's very hard to check our work, but keep an eye out for those things for me.